Hello students, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni, your chemistry teacher, and today we are going to discuss another topic from the same chapter which we have started for this week, that is atoms and molecules. Yesterday we have discussed about atom, we have discussed about some Dalton's atomic theory, we have discussed about the size of the atom. Today we are going to discuss about the symbols for the atom. Okay, these are very important symbols. So first of all, let me first of all tell you some symbols of the atom proposed by Dalton. Yes, so as far as recap for yesterday's session is concerned, yesterday's we have discussed the Dalton's atomic theory, postulates for the Dalton's atomic theory, and then we have discussed the size of atom. Yes, so we are going to discuss today atoms. Okay, so let us start with first hydrogen. Carbon, phosphorus, sulfur, iron, copper, lead, silver, gold, platinum, and mercury. These are the symbols for the atoms of the elements by scientist John Dalton. Okay, yes, so these are the Dalton symbol for the atom. Take a screenshot of this page fast. Just give me a second, I'll just drink water. Till then you can just take a screenshot of this page. Okay, so these are the symbols given by Dalton, but these symbols were not used for longer time because there was discovery of more and more number of elements later on. Therefore, it was difficult to remember these signs. Therefore, IUPAC symbols are used later on. Okay, what is the IUPAC? IUPAC stands for International. I stand for International Union of Pure and Applied Chemistry. Okay, so this was one conference held there. So in this conference, some rules were set up to name the compounds, name the molecules, name give the symbols to the elements present in the nature. So these symbols are used worldwide, and they are common everywhere, right? So there is no confusion in using these symbols. So some symbols you should remember that I am just going to tell you. And apart from the symbols, this table which I am going to explain to you, you should remember all the things related to this table. These symbols are called as IUPAC symbol. So first of all, name of the elements, symbol, elements, symbols, atomic number, and atomic mass. Atomic mass is also called as mass number. Denoted by the symbol capital A. Okay, so what the table which I am going to explain you right now, you have to remember it. Okay, the symbol for at least first 20 element you should know. Okay, yes, so let us start. The atomic numbers and masses of the first 20 element you should know. So I'm just going to write down all of them one by one. Sorry. So first of all, I'll write down hydrogen. Symbol for hydrogen is H. The atomic number is 1. Atomic mass is also equal to 1. Then next, after hydrogen, next element is helium. So as H1 already used for hydrogen, we cannot use H again for helium. So its symbol is He, H capital, E small. The atomic number is 2. Mass is equal to 4. Next element is lithium. Symbol is Li. Atomic number is 3 and mass is equal to 6.9. Or the whole number I can write down 7. Then next is beryllium. For beryllium the symbol is Be. Atomic number is 4, mass number is 9. Next element is boron. Capital B is the symbol. Atomic number 5, mass number 10, 11, 10.8, so 11. Then next is carbon. Symbol is 6, atomic number 6, mass number 12. After carbon, next is nitrogen. Symbol is N, atomic number 7, mass number 14. Next, after nitrogen, it is oxygen. Symbol is O, atomic number 8, mass number 16. Next is fluorine. Symbol is F, atomic number 9, mass number 19. Next is neon. Symbol is N, was already taken for nitrogen, so N is the symbol, and mass atomic number is 10, mass number is 20. After neon, it is sodium. So for sodium, S symbol can be given, but S was already given to sulfur, so therefore sodium has given the symbol Na. This Na, now you will say why it is called as Na. This Na comes from its Latin name natrium. In Latin language, sodium is called as natrium, so that Na are the first two letters of that name natrium. Okay, atomic number for sodium is 11 and mass number is 22. Then next is magnesium. For magnesium, the symbol is Mg. Atomic number is 12, mass number is 23. Just a minute. And mass number for magnesium is 24. Then next, after magnesium, it is aluminium. So for aluminium, the symbol is capital A, small l. Okay, Al, capital A, small l. Atomic number is 13, mass number is 27. After aluminium, it is silicon. So S was already given to sulfur, so symbol is Si. Okay, S capital I small. For silicon, atomic number is 14, mass number is 28. Then after silicon, it is phosphorus. Symbol is P, capital P. The atomic number is 15, mass number is 31. After phosphorus, it is sulfur. For sulfur, symbol is capital S. Atomic number 16, mass number 32. After sulfur, it is chlorine. So C was already given to carbon, so here symbol given is Cl, chlorine. Atomic number is 17, mass number is 35.5. Then after chlorine, next is argon. Ar is the symbol. Atomic number 18, mass number is 39. tetrargon, it is potassium. For potassium P is the symbol, for potassium K is the symbol, not P, because P was already given to phosphorus. So why this K? This K comes from the kalium, which is the Latin name. K is a symbol for potassium. Atomic number is 19, mass number is 40, and then last element is calcium. Ca is the symbol. C was already given to carbon. 20 is the atomic mass, and 40 is the mass number. Okay, so these are the atomic masses, atomic numbers, symbols for the elements. Symbols are IUPAC symbols. Okay, you should remember at least these 20 symbols for the elements, at least these 20. Okay, take a screenshot of this page. It is mandatory to remember at least 20 symbols. Okay, okay, now after this we are going to talk about the molecules. So that's all about atoms. Now we are going to talk about the molecules. Okay, as we know, atoms of different element, they combine with each other and they give the molecules, right? So about molecules we are going to discuss now. Yes, we are going to discuss about the molecules, right? So different atoms combine, atoms of different element combine with each other to give the molecule, right? Okay, so we are going to talk about certain molecules. So molecules of certain elements, they are having only single atom, only one atom. Molecules of some elements, they have, some molecules have two atoms in them, some molecules have 3, 4, 5, 6. So it depends on nature of those atoms and nature of the molecules, right? So molecules of some gases, like inert gases. Okay, molecules of some gases, inert gases are also called as the noble gases. Okay, inert gases or noble gases, they are present on extreme right hand side of the periodic table. So they exist as monoatomic gases. Okay, they exist as monoatomic gases. Mono stands for single, atomic stands for atom, that is they contain only single atom in their molecule, right? For example, if I want to write down the formula for any noble gas like helium gas, so for helium gas I write down the formula as He only, okay, not He2, He3 or He4, right? Its formula is He only because it is single atom present. Inert gases, noble gases, they do not marry any other atom. They are single, bachelor throughout their life. Okay. Then another example, neon. Okay, neon is also the inert gas, noble gas. So its formula is Ne only, not Ne2, Ne4. Then argon. Argon, it is also the noble gas, right? So it is formula is Ar. So they do not like to marry any other atom. They are single throughout their life. They are bachelor, right? So these type of molecules are called as the monoatomic gases, right? They are the monoatomic. Mono stands for single, atomic stands for they contain single atom. Whereas some other gases like oxygen gas, okay, when I say oxygen gas, the formula I write down is O2. O2 stands for two atoms are present. Or when I say nitrogen gas, okay, nitrogen gas. So when I say nitrogen molecule, I write down the formula of N2. Then if I say hydrogen gas for an example, if I write down hydrogen molecule, formula is H2, right? So there are two molecules in that formula. That means they are diatomic. Di stands for two, atomic stands for atom. These are the diatomic molecules, right? So based on how many atoms are present in that particular molecule, we are going to find out the atomicity. Okay, so what is the atomicity of a molecule? It is the number of atoms present in molecule, that is called as the atomicity. Okay, that is called as the atomicity. Now let us see how to find out the or how to identify the atomicity. So first of all, let us see element and their atomicity. Okay, one by one let us see. First of all, hydrogen gas. Okay, before hydrogen gas I will write down helium, neon, argon. These are the noble gas. For them the atomicity is, it is monoatomic in nature, right? They are monoatomic in nature. Okay, then I will write down the next, that is oxygen, hydrogen, nitrogen, chlorine, bromine, iodine. Okay, then all these gases are diatomic in nature. Di stands for two atoms are present in their molecule. Their atomicity is equal to 2. Okay, then other examples I will write down. The phosphorus. Phosphorus is tetraatomic in nature. That is the formula for phosphorus is P4. Okay, P4 is the formula. We write down the formula P4. Then next example I will write down is the sulfur. So sulfur exists in the nature in the form of S8 molecule. Okay, S8 means it is octaatomic. Octaatomic, or it is also called as polyatomic. Octaatomic, or it is also called as polyatomic. The formula for sulfur is S8. Okay, yes. So this is about the atomicity. Atomicity is nothing but the number of atoms present in that molecule. Okay, take a screenshot of this page also. Okay, now these are the examples in which same type of atoms is present. Now there are certain examples in which different type of atoms are also present, right? Okay, I'll write down those examples also, like CO. Okay, so CO is carbon monoxide, so this is diatomic in nature, right? CO2, there are 3 atoms, so it is triatomic in nature, right? H2O, there are again 3 atoms, so it is also triatomic in nature. Okay, then NH3, ammonia, there are 4 atoms, so it is tetraatomic in nature, right? So based on what is the number of atom present, we are going to write down the atomicity. Okay, now after atomicity I am going to tell you another thing here related to molecule, and that is called as ratio by mass. Let us see how to find out the ratio by mass, or it is also called as mass ratio. Ratio by mass, or it is also called as mass ratio. How to find out the ratio by mass, we are going to discuss. Let us start with very simple example of water molecule. Okay, H2O is the formula. We know atomic mass of hydrogen is 1, atomic mass of hydrogen is 1, and atomic mass of oxygen is equal to 16. Atomic mass of oxygen is equal to 16. We have seen this in this table, right? Now therefore ratio, what will be the ratio? Therefore hydrogen as to oxygen ratio will be equal to, there are 2 hydrogen atoms, so it is 2 adds to 16, right? Hydrogen as to oxygen ratio 2 as to 16. Why I have taken 2? There are 2 hydrogen atoms, right? 2 as to 16. 2 as to 16 can be simplified as 1 as to 8. Okay, 2 as to 16 can be simplified as 1 as to 8. So what is the ratio by mass for hydrogen? It is 1 as to 8. Next example we can have, another example is ammonia. Okay, ammonia formula is NH3. Okay, ammonia. Now in ammonia there are again 2 types of atoms. One is the hydrogen, another is the nitrogen. Atomic mass of nitrogen is equal to 14, right? And that of hydrogen is 1, and that of hydrogen is 1, right? Okay, therefore what will be the ratio? Yes, so ratio will be, therefore nitrogen as to hydrogen ratio is equal to 14 as to 3, right? 14 because only 1 nitrogen, 3 because 3 nitrogens are there. This ratio cannot be further simplified. Therefore mass by ratio is equal to this. Next example we can have carbon dioxide, CO2. Okay, now in CO2 atomic mass of carbon is 12. Atomic mass of carbon is 12, and atomic mass of oxygen is 16. Of oxygen is 16, right? Therefore the ratio, therefore carbon as to oxygen ratio will be equal to, only 1 carbon, so 12, 2 oxygen, so 16 into 2, 32, right? So this can be simplified as the 3 as to 8, right? Yes, if we divide both the sides by 4, we will get 3 as to 8. So 3 as to 8 is the ratio by mass, or mass ratio for carbon dioxide. Okay, yes, so just take a screenshot of this page. Now this ratio by mass we are going to use further to find out the simple ratio of atom present in the molecule. Okay, take a screenshot. I hope you understood how to find out the ratio. Just you have to write down the masses and you have to simplify the ratio. That is called as ratio by mass or mass ratio. Okay, now this mass ratio, calculation of mass ratio will be useful for another type of questions which we are going to discuss in the next class. Okay, I hope you understood these concepts which we have discussed today regarding the atoms and molecules. First of all, we have seen the Dalton symbol, then IUPAC symbols, and then we have seen about molecules, atomicity of molecules, and then we have seen about the ratio by mass or mass ratio calculation. I hope you do not have any doubt. If you have any doubt, you can ask me anytime in the chat box in today's class or in the next class as well. So that's all for today. So before ending the class, let me just show you DPP, daily practice problem. So this is a teacher's portal. Same will be for the student. You have to go to resources, then to writing material, wherein you can see DPP. You can download this DPP, daily practice problem, solve it on a notebook, take a picture of that notebook and just upload it on the portal. So teacher will be able to see that. Teacher will evaluate it and tell you the suggestions and corrections wherever required. That's all for today. Thank you so much, students, for your precious time, and all the best to you. Thank you.